stability, and consequence. Traditional notions of right and wrong are situated within each individual branch, yet awareness of alternative outcomes may influence moral reasoning. Some philosophers argue that multiverse thinking encourages greater compassion, understanding, and perspective-taking. Recognizing the diversity of potential lives reinforces empathy and humility. Others explore implications for identity, continuity, and existential meaning. These considerations demonstrate that engagement with multiverse concepts extends beyond physics and mathematics into the domains of ethics, philosophy, and human experience. Probability and statistics acquire new meaning when considering parallel realities. Classical probability assumes a single unfolding of events where unlikely occurrences have low chance. In a multiverse, all possibilities are realized somewhere, altering the interpretation of chance. Rare events that appear miraculous in one universe are commonplace across a broader ensemble. This perspective provides insight into fine-tuning and anthropic considerations. Observers naturally find themselves in regions compatible with life, not because these regions are favored, but because only such regions permit observation. The statistical reasoning expands to consider distributions across universes rather than a single sample. This shift in perspective influences cosmology, particle physics, and philosophical reflection on contingency and necessity. Experimental approaches continue to probe the boundaries of the multiverse concept. Cosmologists analyze the cosmic microwave background for anomalies, suggesting collisions with other bubble universes. Particle physicists conduct precision measurements, looking for deviations from expected behavior that could indicate higher dimensional interactions. Quantum experiments manipulate entangled particles and superposed states to explore branching phenomena and coherence. While direct confirmation of parallel realities remains elusive, the pursuit informs methodology, theoretical modeling, and interpretation. Each experiment refines understanding, narrows possibilities, and inspires new avenues of inquiry. The dynamic interplay between theory and observation exemplifies the evolving nature of scientific exploration into realms once considered purely speculative. Cultural and educational dimensions reinforce engagement with multiverse ideas. Literature, cinema, and visual media increasingly incorporate branching realities and alternate selves. These narratives provide intuitive access to complex scientific concepts and stimulate curiosity. Educational frameworks leverage thought experiments and analogies to convey multiverse principles without oversimplifying. Encouraging audience interaction, reflection, and speculation promotes deeper comprehension and personal connection. By bridging science and imagination, these approaches cultivate a culture of inquiry where wonder complements rigor. They demonstrate that exploration of parallel realities is not only a scientific endeavor, but also a humanistic pursuit that expands both understanding and creativity. Technological analogs offer tangible connections to multiverse thinking. Quantum computing illustrates how superposition and entanglement allow simultaneous exploration of multiple computational pathways. Optimization problems are addressed by effectively navigating a landscape of parallel possibilities, analogous to multiverse branching. Quantum cryptography exploits entangled particles to achieve secure communication, reflecting fundamental principles of interconnected realities. These applications reveal how abstract theories inform practical technology and underscore the relevance of foundational research. They demonstrate that concepts derived from multiverse models can inspire innovation and real-world impact beyond theoretical contemplation. Engaging with the multiverse enriches human perspective. Considering alternate versions of oneself encourages reflection on choice, consequence, and potential. It fosters appreciation for the complexity of life and the interdependence of events. Even in the absence of empirical verification, the exercise cultivates mindfulness, intentionality, and philosophical exploration. Thinking in terms of multiple realities encourages expansive thinking, problem-solving, and creativity. It bridges scientific inquiry and existential reflection, allowing individuals to situate personal experience within a broader cosmological framework. This interplay between knowledge and contemplation exemplifies the value of integrating scientific insight with human experience. Observation and consciousness emerge as recurring themes. The relationship between measurement and outcome in quantum systems invites reflection on the role of awareness in shaping reality. While speculative, this perspective inspires interdisciplinary dialogue, linking physics, philosophy, and cognitive science. Exploring potential interactions between mind and multiverse encourages critical thinking and intellectual curiosity. It challenges assumptions about the nature of existence and the boundaries of human understanding. By engaging with these ideas, viewers are prompted to consider not only the structure of reality, but their own place and participation within it. Observation becomes not just a passive act, but a lens through which the richness of existence is apprehended. The concept of parallel realities has fascinated humanity for centuries. From ancient myths to modern science fiction stories, we have always wondered if our choices create different paths in other worlds. Today, theoretical physics provides a framework to explore this question seriously. What if every decision you make spawns a new universe, where a different version of you experiences an alternative outcome? This is the mind-bending idea at the heart of the multiverse. Unlike science fiction, these theories are grounded in equations, observations, and models that describe how our universe operates at its deepest levels. By examining these ideas, we begin to challenge the very nature of reality and our place within it. Parallel realities invite us to question our assumptions about uniqueness. Imagine a universe where your life took a different turn. Perhaps a decision made yesterday created an entirely separate timeline. This is not merely a hypothetical scenario, but a potential implication of quantum mechanics. At the smallest scales, particles behave in ways that allow multiple outcomes to exist simultaneously until measured. This principle, known as superposition, hints at the possibility that countless parallel realities are occurring alongside our own. In this view, each choice branches into a new timeline, producing infinite versions of events across the cosmos. The idea is staggering, yet supported by mathematical frameworks that extend our understanding of the universe beyond what we directly perceive. Inflationary cosmology provides another path to the multiverse. According to this theory, the early universe underwent an exponential expansion, producing vast regions of space with slightly different properties. Some of these regions could be entirely separate universes with their own physical laws. The sheer scale of inflation implies that universes could be created continuously, forming a cosmic landscape far larger than the observable horizon. In this scenario, our universe is just one bubble among countless others, each evolving independently. This model suggests that what we see is a tiny fraction of the total reality and invites us to imagine the infinite possibilities that lie beyond the observable cosmos. String theory and the idea of brane worlds offer an even more radical perspective. In these models, our universe exists as a three-dimensional membrane floating in a higher dimensional space. Other branes could host entirely separate universes parallel to our own. Occasionally, interactions between branes might produce observable effects in our universe, such as gravitational anomalies or cosmic collisions. This framework challenges our intuition about space and dimension. It implies that the multiverse may not only exist in terms of possibilities within our universe, but also as a literal spatial structure beyond what we can see or measure. Understanding these higher dimensional interactions requires rethinking physics from the ground up and opens doors to phenomena that were once purely speculative. Quantum mechanics further complicates the picture. The famous double-slit experiment and the many worlds interpretations suggest that all possible outcomes of a quantum event are realized in separate branches of reality. Each time a particle can take multiple paths, every possibility occurs somewhere in the multiverse. This framework explains why quantum mechanics seems probabilistic, yet fundamentally deterministic at the multiverse level. It also provides a striking resolution to paradoxes such as Schrödinger's cat, where conflicting outcomes coexist in separate realities. Engaging with this interpretation challenges our perception of time, causality, and individuality because it implies countless versions of ourselves exist simultaneously experiencing different events. Current observations push the boundaries of what evidence might exist for parallel realities. Gravitational waves and patterns in the cosmic microwave background radiation could carry subtle signatures of other universes. Some theories predict collisions between bubble universes may leave imprints detectable with precise measurements. Advanced telescopes and detectors aim to search for anomalies that cannot be explained by standard cosmology. While direct proof remains elusive, these investigations expand our scientific toolkit for exploring the multiverse. They also demonstrate that even speculative concepts can be subjected to empirical scrutiny, guiding our understanding of the cosmos. The implications of parallel realities extend beyond physics into philosophy and human self-perception. If multiple versions of ourselves exist in parallel universes, the notion of uniqueness must be reconsidered. Every choice we make could produce an infinite array of alternate lives where outcomes differ in small or significant ways. This raises questions about free will, responsibility, and identity. Do we truly shape our destiny if every possibility is realized somewhere else? Does knowing that alternate versions of ourselves exist diminish or enhance the meaning of our experiences? Engaging with these questions forces us to reflect on the nature of consciousness and the significance of our actions within a vast, multiversal context. Understanding the multiverse also reshapes our perspective on human significance. In a cosmos filled with countless realities, our existence may appear less central, yet simultaneously more remarkable. Each universe represents a unique manifestation of physical laws and events, yet we occupy a privileged position in our observable universe. The recognition of infinite possibilities inspires awe and humility while challenging anthropocentric views. It encourages curiosity and exploration as we seek to comprehend the larger structures